Good morning, students. In the last lecture, we discussed surface tension on the basis of molecular theory, and we also seen some terms which are important in the molecular theory. In today's lecture, we are going to discuss the surface tension and surface energy and the relation between these two terms. First of all, we see what is the surface tension. We will see the definition, SI unit and dimension, and then we are moving to the surface energy. So, what is surface tension? In the last lecture, we explained the surface tension on the basis of molecular theory, but we can't define the surface tension. The surface tension can be defined by in easy way. Consider a free surface of liquid, the overview of a free surface of liquid, and an imaginary line is drawn on the surface. Now, we have seen that in the molecular theory that the molecules on the free surface always try to go inside the liquid due to the attractive forces. Now, in this case, forces are acting on this line, imaginary line, in all directions. If we consider that the length of this imaginary line is equal to L, then the surface tension can be defined as the surface tension is denoted by T. It is nothing but the force acting per unit length. So, what is T? This T is equal to F divided by L. What is F? F is a force acting perpendicular to this line and tangential to the surface. And what is this L? L is the length of this imaginary line. Therefore, what is the surface tension? Surface tension is equal to force per unit length. Now, what is the SI unit of the surface tension? The SI unit of the surface tension is equal to Newton per meter. And what is the CGS unit? The CGS unit is equal to dyne per centimeter. What are the dimensions of this surface tension? The dimension of surface tension can be calculated if we know the dimension of force and dimension of length. What are the dimension of force? It is equal to m1 L1 T minus 2, and what are the dimension of length? It is equal to L1. This L1 L1 cancel, and what are the dimension? It is equal to m1 L0 T minus 2. These are the dimension of surface tension. So, here we define surface tension and we also get the SI unit and dimension of surface tension. Now we are moving towards the surface energy. What is surface energy? In last lecture we see that all the molecules on the surface are trying to go inside the liquid due to the attractive forces, due to the cohesive forces. Now, if we need to bring a molecule from the bottom of the surface to the bottom of the liquid to the surface of the liquid, we need some work to do to bring a molecule due to the cohesive forces which are acting in a downward direction, but we bring the molecule from the bottom to the layer that is in the upward direction. So we need some work to be done. Such work, such energy is called as the surface energy. Or we can also define this surface energy as the energy of the molecules on the surface of the liquid is larger as compared to the energy of the molecules when they are placed at the bottom. The extra energy possessed by the molecule on the water surface, the extra energy possessed by the molecule which is placed on the surface, it is called as the surface energy. Now, what is the property of surface tension? Surface tension always try to minimize the surface area of the liquid, because the molecules are trying to go from the surface to the bottom due to the lesser potential energy. Any particle, any system will be equilibrium when it is at the state of less potential energy. So the molecules are trying to go inside the liquid, therefore the surface area of the liquid decreases. And if we have to increase the surface area, then we need to do some work against the cohesive force. So this is all about the surface energy. What is surface energy? The extra energy possessed by the molecules on the surface of water as compared to the molecules at the bottom is called as the surface energy. Now we are moving towards a simple relation between surface tension and surface energy. For that, we consider a frame of wire PQRS in which three sides are fixed, but this QR can be slide over this PQ and SR. So if we dip this frame of wire inside a soap solution, a soap film is developed between this P, Q, R and S. Okay, now as we say earlier that what is the property of surface tension? Surface tension always try to minimize the surface area. So on each side a force is acted to minimize the surface area of this soap layer. Now as these three sides PQ, PS and SR, they are fixed, they won't able to move, but this side QR can slide, can minimize the surface area of the soap liquid. So a force is acting inwards towards PS such that the surface area of this soap layer decreases. Now what is the force acting on this side QR while it is decreasing this surface area? So we know that what is surface tension? This surface tension T is equal to F divided by L. Now therefore what is the force? This force is equal to this surface tension multiplied by twice L. This factor 2 arises due to this soap bubble has two surfaces, front surface and the back surface. Therefore, a factor 2 arises here. So, what is the force acting on this QR? This QR force acting is equal to T multiplied by twice L. So, the surface area of the soap bubble goes on decreasing while this force is acting on this soap bubble. Now, what happens next? If we have to increase the surface area, by an amount dx, we have to increase this length of the wireframe by an amount of dx, then we need to do some work. We need to spend some energy to bring this QR to the position Q dash and R dash. If we pull this QR by an amount dx, the energy or the work done is dW, which is equal to F multiplied by the displacement, which is equal to dx. Now what happens next? This is equal to, what is F? It is equal to surface tension T multiplied by twice L and it's multiplied by dx. So what is L multiplied by dx? This L means this length and multiplied by dx, it is nothing but the area, change in area. So we can write here as dA. This is d dw is equal to f multiplied by dx, but we know what is f is equal to t multiplied by twice l. T multiplied by twice L multiplied by dx. What is L multiplied by dx? L multiplied by dx is nothing but the area. Okay, area of the front side. Similarly, the area of the back side, therefore it is equal to twice of the area. It is equal to nothing but the dA. So we can write here dW is equal to T multiplied by dA. But this work done is stored in the form of energy. As we see earlier in the definition of surface energy, what is surface energy? Surface energy is the energy of a molecule when it brings from the bottom of the liquid to the surface of the liquid. Here we are doing same thing. We are increasing the surface area. We are bringing this molecule from this position to this position. So this work done is stored in the form of energy, and such energy is called as a surface energy. So we can write here this surface energy is equal to surface tension multiplied by dA. So this is a simple relation between surface tension and surface energy. We can also write this surface tension T is nothing but the surface energy per unit area. That is surface energy divided by dE. So surface tension can be defined in other way as it is nothing but the surface energy required to increase a unit area. So in this lecture we discuss about the surface tension definition, its SI unit, CGS unit, its dimension. We are moving towards the surface energy, and then we derive a simple relation between surface energy and surface tension. So in this lecture we discuss all about the surface tension and surface energy. We are going to stop here. We will see in the next period the another property of the surface tension. So have a nice day. Goodbye.